Okay, so we will spend a little bit time to study the matrix of array, multiple dimension array of C# programming language. Okay, so you can open a project and following the step that I'm going to go through step by step. So probably you will learn more about the arrays or multi-dimension arrays of C# programming language. So supposedly I randomly add a console application. So it's purely text mode. There's no right. Okay, I simply just create a console application. So there is no any graphics user interface at all. But actually, you still can develop certain kind of application. This application does not need any graphics user interface. All right, so it's a C# project, so it's a console project. As you can see, the wizards or Visual Studio create a class for you, define a class, because there is no any so-called global function at all in C# programming language. All the functions should belong to certain kind of type, for example, class or structure. So main function is the entries, is the entry point of C# application. But again, that main function should be specified within the type. So right now it's a class. So okay, so program always start from here. All right, so in main function, sometimes you declare a variable, right? That's the variable. We call it local variable. Local variable just exists within the scope of this function. When this function is complete, then this variable is no longer exist. Okay, but for the data member or data field or class, it exists always exists there. Name-wise, they can be the same because the computer will not be confused with the I. But in order to distinguish the member I and the local variable I, if you want to access the member I, you need to use this keyword. This means this object. When an object is instantiated, you need to do that in that way. Okay, but why the problem you cannot see here is because main must be declared as static. Okay, so I cannot access this. Static meaning what? Meaning what? I do not need to instantiate an object or program at all. I can directly invoke this main function. So main function is a special function. You need to follow a certain kind of rule. Main function should be always static. That means we do not need to instantiate an object or program in order to access main function. So that is the regulation. But if I define the function within this class, suppose it's a f function. So right now f function is not static, right? So if this f function belongs to an object of this program class, and this I belong to an object of the program or the objects of the program class, so they can access the I. There's no problem. So suppose here I have a local variable. I still can define a local variable. The name is the same as the data field. But in order to distinguish both of them, you need to use this keyword. This means this object assigned with the new value, something like that. All right, so that is the so-called local variable. The difference between local variables and data members somehow. They can bear the same name. There's no problem. All right, so as you can see, the keyword means in blue color. In those cases, that is the keyword, right? That is the keyword of the C# programming languages. So int is a built-in data type, built-in data type of C# programming language. And it is value type. How can you distinguish a value type and a reference type? Almost all the data type of C# programming are so-called value type. For example, int, double, float, and probably is the no, never mind. This data type is kind of primitive data type, right? So they are always so-called value type. The only another one is structure. Okay, structure is a class is a user-defined data type, right? And if you have struct, we call it probably SS, fine. And within this structure, we have defined data field, for example, INJ, something like that. So struct is a keyword or C# programming language. Once you define user structure, SS is a value type. So suppose I have SS. The SS is defined by the user, right? S1, for example. And how about the class? So right now I have a user-defined type called, the name is whatever. What is a class? SS is a struct. And the SS is, structure is actually a value type. Later on we will see what's going on. Value type. But the Y1 is a reference type. So C# programming provide user-defined data type, right? In two kinds of data type. One is struct, the other is the class. So struct is quite similar to the C struct data type too. I mean, if you are familiar with the C or C++, you have struct. By that time, as in before object-oriented techniques came out, in C programming language, we usually use structure to aggregate a bunch of data together and then name it as a new data type. That is the old story anyway. In C's ages, okay. All right, so the keyword, the built data type, most of them are so-called value type, but there are only two different. Two data type in C# embedded data types are reference type. The first one is your object, which is O. Right, it's a reference type. And the other one should be string. String is very special. Is a special reference type stuff. Once you use the string, it looks like it is a value type, but in fact, behind the string, as I think probably I have mentioned that before. I mean, in somewhere in the lab, it actually is a reference type. So how can you distinguish value types from reference type? Well, it's very simple. Once you debug your code, for example, I have put the value here, 33, so I can make a stop point right here. So you go through debug mode and then check the value, current values or local variable. You can see certain kind of hint telling you that what data type all these variables are. All right, so local variable right here. So you check the value, right? What does that mean in value? The value is a 0101 pattern. I mean, store in this memory, right? In this variable, right? So I have a local variable argues ID, F, S1, Y1, O, S, right? As you can see, I did not assign any value yet, but there is an initial value specified there. All right, so as you can see, 0 is a value, right? 0 value, right? And how about Y1? Y1 is a class. So class initially is none. So it's a reference type. O is a reference type, S is a reference type 2. How about the struct? The structure we define here, SS. SS is a value type. Why? Once you unfolded the S1, you can see there are two values already exist there. All right. But if in my struct, if I have a SS object, all right. How about the How about the Y1? Again, because Y1 S1 is a structure. So S1 itself is a structure. Oh, excuse me, not here. Sorry. Within the struct, I might have YOBJ data there. So let us restart the program. It's almost the same, right? I0, D0, F0, so they are value type. And Y1 is class, object is class, String is a special type, but it is a reference type. So initially they are all none. How about the S1? S1 is struct, so no problem. S1, the data has exists there. 0, 0. But Y objects, yeah. Y object is a reference type. So Y object, you see, initial value is none. Okay, so if you have a C++ programming language background, you simply can treat this non stuff, so-called reference type, as pointer. Pointer is a variable. So this time it pointed to one data. Next time it can be old, can change it. Since it's a variable, you can change the variable to point to another one. So that is the whole idea about the pointers in C, C++. But right now it's the same. In C#, we do not call it a pointer, but we call it as a reference type. So reference type, what kind of data has been stored? None. Right now, none. So in order to create data contents of this type, you need to new it. You need to use new operator to allocate memory for this class. For example, I have YY class, right? The I and the J has not existed yet. It has not been instantiated yet. So the whole thing, Y1 is none. You need to dynamically allocate memories. Once the memory has been allocated, then that object is complete. The object is complete. But the variable Y1 hold is just the starting address only. And Y1 is a variable again. It is a variable. So Y1 can be ordered. The content of Y1 can be ordered. And then once it is ordered, it will point to another object. So that is the whole idea is behind the reference type of C# programming language. It's quite similar to the C++ pointer. So keep that in mind. All right, but if I have okay, so right now we know it's a reference type, but if I have an array, for example, int array, the array type is very easy. I mean, for C# programming is much more meaningful. I mean, we just use an empty right bracket associated with a type. So right now it's an array, and if I keep the name there, so once it is an array, the I array is not the same as the I array right now is a reference type. Even though the array store real type data int, but since it's an array, so right now it's turned out to be a reference type. So as you can see, once it is an array, then IARY initial value, as you can see, IARY is none. So you need to dynamically allocate memory, and then this array can be functionally normally. Otherwise, there is no any element exist yet in this array. And as you can see, what I just put here, IARY is a one-dimensional array, right? But for the C# programming, it's very nice and it's very considerable. I mean, comparing with the C and the C++, it provides so-called rectangular array, right? So IARY. So again, IARY is is an array too. So once it is an array, then it turns to be the reference type. So you can see IARY still is a none, all right? And sometimes probably you prefer, I mean, the kind of array int array. So right now, it does not matter what kind of structure, of this multiple dimensional array or array. Actually, it is a reference type, so you know that. But what is the difference between these two? Okay. So let me show you. If up to this point I have IARY kind of new int, so you need to supply the number, fixed number. So I have 10 there. Okay. And IARY, I need to new it, and I need to supply the dimension of all the dimension, right? I need to specify the size of all the dimensions. So for example, I have 2, 3 there. But it also sometimes you might think that AARY is a two-dimensional array. And the definition is quite wrong. AARY is actually a one-dimensional array. See right here, it's one-dimensional array. IARY is again one-dimensional array, right? But the IARY, the element of this one-dimensional array is what? It's an INT. So IARY is a one-dimensional array. AARY is a one-dimensional array. The element in AARY is an INT array. So you need to think of that in that way. But how about IARY? IARY is a two-dimensional array. Oh, okay. So suppose I have another one. Eventually you will have this, you need to use this kind of structure later down. Probably, I cannot remember, probably not. But it's a three-dimensional array, right? So IARY. So it's a three-dimensional array. But sometimes, again, you might have a more complicated array structure. I have three-dimensional array. Right now, up to this point, the array type is INT. But I still can use it to run. No, I am a three-dimensional array. The element, the type of element is INT array. Okay, you need to think in that way. So it's array. All of them are array, right? They are all reference type. But in order to populate the element, you need to know it. I mean, dynamically know it. I mean, new allocate memories on the heap for this storage of the element anyway. But you need to know the element type stored in this array. So it's a three-dimensional. So how do we know that? All right. So suppose I have dm1 equal IARY. There is a property. I mean, so for any array, there is a property called rank. Rank is meaning what? Meaning dimension. So let us check the IARY rank. I need to know it first. All right. So IARY, what can I have it prepared right here? IARY, right? New. How about IARY? Okay. IARY equal new int 2, 3, 4. And so let us treat that data. Okay. So let us check about this so-called, because these three is array, right? We like to know the rank. dm1 IARY. Okay, yes, okay. Size. Size. IARY. Rank. INT ISS. So far, I mean, we have local variable list right here. So they kind of, I mean, have initial value, especially, right? So all these arrays are reference type this moment. So then we execute the statement one by one. So we allocate, I mean, up to this point, we allocate 10 INT size memories on heap. And then once computer allocate memory, it will return the starting address back to you. So once computer executed this statement, a pointer, or actually not a pointer, an address, memory address will be sent back to you and let you assign that starting address to IARY. So far, IARY has not been assigned any value yet. But once this line is complete, IARY actually hold the contents of IARY, the variable, just store the starting address for that 10 element. So in that case, we can access this element again. I mean, through this IARY variable. So IARY, the value stored in IARY is simply the address, starting address. So once the user want to access IARY 0, then it will just calculate the memory address. I mean, start for another 4 bytes. So it can the value stored in the memory can be accessed. through this kind of notation, your code. All right. So similarly, IIRY allocate 2 by 3 has been allocated one shot. So totally there should be 6 elements, right? 6 elements has been allocated within IIRY. Okay, so they are already there. So right now, IIRY is no longer number. IIRY is no longer number 2, but IIRY is about to instantiate. So once IIRY is ready, right? It's a 3-dimensional array. So IIRY, as you can see, 1, 2, 3, right? This is the last one. Okay, so they are all variables. So right now we're just simply interested about the rank. So ISS, as I IAR, as I just mentioned, is a 1-dimensional array. It's 1-dimensional array. It's 2-dimensional array. It's 3-dimensional array. So you can see the rank ISS is 1. Actually, you can move the mouse right here. Rank is 1. How about IARY? Rank is 2. IARY rank is 3. Right? So it's simple. 3-dimensional. In addition to the rank, there is another property called what? Array length, int, IARY dot length, int, II1, IARY length, int, II1, IARY length. So we have another property to let you understand the data structure stored in this array. So let us move your cursor. It's simple. You don't need to execute this line. So rank is 1, rank is 2, rank is 3. How about the length? You see, so we simply just allocate memory via one statement, right? So element-wise, well, I definitely there should be 10 elements stored. 10 elements of what type? INT type, right? The element within this IRY is INT. So it's INT, 10 INT, length is 10. How about a 2 by 3? 2 by 3, 2 times 3, right? So the length should be 6. And how about the third one? 2 times 3 times 4, 24. So we can see, move your cursor right here. Length, 10, right? 10. 2 by 6, so 2 by 3 should be 6. 2 by 3 by 4 should be 24. So that's the length. Okay, so for this 2-dimensional array, 1-dimensional array, is straightforward, right? But the problem right now we are facing is the this kind of array, right? So we call these arrays rectangular array. It's a rectangular array because every dimension, each row should have the same number of columns, right? Each column should have the same number of rows. So it's a rectangular array. It's pretty decent. Comparing with the C++ programming, this array help us perform a lot of mathematical computation. It's very, very nice. Okay, but for the C++ programming, you don't have this kind of array, right? What you have is just 1-dimensional array. So it's interesting. Comparing these two, right? These two. It's this 2-dimensional array, or otherwise we might have another one, right? AAARY. So what is the rank? The rank should be the dimension, right? What is the rank of this array? What is the rank of this array? What is the rank of this array? So let us check that. Maybe I don't need to write it down. So we can. But we need to instantiate it first, otherwise you cannot see anything. So at this point, AARY, so we concentrate on this AARY. So since it's we call it jagged array, JAGGE, jagged array. Meaning what? Meaning, well, although you think probably it's 2-dimensional, actually, in fact, it's a 1-dimensional. It's a 1-dimensional array. What is the element? The element is INT array. Since the element is an INT array, right? Array is not fixed there, so each element can have different kind of lengths. So what your array might look eventually might have this kind of situation. So probably the first element I have allocate 2 elements, and then probably the second element I might, well, let me try to do it in this way, 2, and I might have no instantiate yet. I might this one. So I might have okay, let me show you 3, 2, 0, 1, right? 3, 2, 0, 1. Okay. So in this case, 3, 2, 2, so I need a 2 instantiate array, right? Instantiate memory, right? So initially I have a new int. How many? 4, right? I have 4 elements. So AARY is actually a one-dimensional array. What is the element? Element is another int array. So that is the cases. So the statement should be doing this way. You see, this array will be this statement will have trouble, right? Because the right hand side, what you allocate is just a one-dimensional int array, not int array. Okay, so very clearly I came out. So you need to instantiate the length. I mean the number of elements for the first layer. For the first layer. So I kind of instantiate the 4, and then I can dynamically allocate another array, ARY, the zeros, right? What I have instantiated is new. So this time is int. Allocate, I believe that should be 3, right? 3. ARY 1 new int 2. 4, 3, 2, 1, right? 2, 1. And I did not allocate anything for ARY 2. I simply allocate ARY 2 new int 1. It's allowable, but you cannot say 0. All right, 1 is okay. I believe you cannot. Well, still acceptable, right? Interesting, right? Never mind. So, what I'm interested in is that what is the length? Rank. AARY rank. How about the length? AARY length. Right? We like to know. I'm using the structure. So right now ARY is actually, as I mentioned, in fact, it's a one-dimensional array. The element is the int array. Okay. So let us execute it. AARY. AARY is none. How come? Extension 4 0 1 2. Do I need to specify it? So I need to 0 1 2 3. So that should be 3, right? 2. I set it to none. Do I need to do that in order to get a rank? Anyway. So I instantiate 3, right? 3 element, 2 element, without instantiating anything for the array 2. So, so up to this point, you can see initial value ARY is none, right? So it's a reference type. Then ARY right here, instantiate 4 element. 4 element or what? What kind of data? 4 element int array. So you see, as you can see, it's ready right now. Once you unfolded the ARY, it's a one-dimensional array. It's one dimension. Remember that it's a one-dimensional array of 4 elements. What is the element? It's not int, so it is not 0, right? It's an int array. So int array is a reference type. So you see, the initial value is none. And then, so we step by step instantiate 3, right? So for the 0, we instantiate 3. So as you can see, the 3 is already there. It's a value type, int is a value type. So initial value is spatial there. The first 2, you see 2 elements. And then the second one is none. I did not instantiate anything. And how about the index 3? I instantiate the just one element. She's just one element there. So later on, you can use what AARY, the right bracket in the first index and second index in that way. But the interesting is what is the rank? Move your cursor right here. 1. Rank is 1. So it is a one-dimensional array. How about the length? You might think, oh, the length is related to what? To the element 3 plus 2 plus 1, 6. No. The length is 4. So length always restricts to the first layer. How many elements exist in this one? Since it's one-dimensional array, rank is 1. So rank is 1. The element 1 is just the number you instantiated in the very beginnings. So I just have 4 elements. Okay, so this array we will be frequently using it. So you need to know what's going on behind this kind of array. It's a jagged array. By default, it can be jagged array. But again, I might use this this one-dimensional array or int array with the same size, right? So for example, I might have the same size 5, 5, 5, new int. So it looks like a rectangular array, but in fact, it's not rectangular array. It is still a one-dimensional array. The element is an array. We prefer this kind of data structure because what? Because each row can be fetched, and pass data to a function we would like to evaluate solution, right? So that is the purpose we want to use. But sometimes this two-dimensional array was much easier for you. For example, your pheromone matrix, we will use this rectangular array to store our data. It's much more easier to access. If you use this so-called jagged array, you need to know memory label by label. And you need to know, in fact, it's a one-dimensional array. The element is an array too. And how about this kind of array? So now you need to induce this idea. So BARY is a three-dimensional array. It's a three-dimensional array. What is the element? The element is an int array. So if I instantiate this guy for you, new. So the first thing is you need to specify the size of the first layer. So the first layer problem I'm at 2 by 3. Again, since it's a 2-layer array, so you need to instantiate the data 1 by 1. Okay, int, right? So BARY is an int array. What is the element? The element is none. So okay, probably we make a stop point right here, break point here. So, all right. So we are about to instantiate memory for the BARY. BARY again is an array, right? So it's a none. So, but once instantiated, see, BARY right now is an int 2 by 2 by 3. So element-wise, you can see they are already there. But what is the value? What is the value? The element or this value is int array. So it's a reference type. It's none. Each element can be instantiated by different kind of size. You know. So probably I do not allocate memory for this element at all. So I do not allocate int array here. I'm going to allocate probably 5 elements for this element, right? So layer-wise, you can trace that there is a certain kind of logic following this convention. So you need to identify. So how about the BARY, the length and the rank? Move your cursor to the BARY. Check the property right here. No way. Okay, see. So I still need to check it. So there is another window called monitoring, I think. So you can type any variable. So if I type BARY dot rank, you can immediately get the value. So rank is 3, right? It's a 3-dimensional array. What is the element type? The element type is int array. How about the length? BARY length. It is known right now, even though I did not allocate real element at all, but right now it's 2 by 2 times 2 times 3, so element length is 12. Okay. All right. So another property I'm saying very useful in here is that, for example, okay, for this rectangular array, for example, int, you might define a function accept, for example, this 2-dimensional array, right? It's a rectangular array, but they did not provide any length information for you. So suppose I kind of new aggregate memory, probably 2 by 3, right? And what you get, I mean, you might simply have function. For example, I have function f. I call function f, and I put IARY, pass that as an argument. So I have static function. I need a special static function, static f function, void. So sometimes you define a function, and what you take is just an int, a 2-dimensional array. So the user simply pass an array to you, right? F, IR1. And then you need to look through all the elements. How can you do that? So usually you have R4, R, int, R equals 0, R smaller than row number. So I did not have any row number, right? But in C#, if it is an array, you can you can access the related property through a function called property. You see, last time we have a length, right? But you should not use length. Length is a total number element, right? So if you want to get, since the rank right now is 2, right? If you want to get the dimension of each rank, or each, if you want to get the size of each dimension, you should use getLength. Dot get length. And check about the help information here. Get length. You supply the dimension ID there, so you will get the number of that dimension, the size of that dimension. So you need to give that. So row wise should be the 0th dimension, right? So you get the row number through this function call. You may prepare a local variable to store that. Otherwise, you should use this way. C smaller than array get length. The first layer. So that should be the color C++ sum up there. So you need to do that. So it's very, I mean, it's very beautiful. I mean, for C# programming, you don't need to provide extra information about the row number and column number at all. You simply pass an array to the function. Okay. But how about the JQuery array? JQuery array, what you can get is simply just stepwise by stepwise. So suppose right now I have a JQuery array AARY here, and AARY instantiate how many instantiate? Probably the element is 4, 5, right? Since it's JQuery, right? So you might expect that, well, each element will have different kind of array lengths. So ARY zeros. New int probably 4. ARY 1. New int 3. Probably just this, like this. And I might have a function G. I pass AARY there. It's clear that it's an array of array, right? So it probably. So similarly, if you like to go through all the elements, how can you do that? Well, similar to this kind of get length, right? So actually, since it's a one-dimensional array, right? If you like to go through each row, we still call it a row, right? Start from 0. Well, in this time, you can use smaller than a dot length, or you still can use get length zeros. Let us see. If they are whether they are the same or not, row-wise, right? But in this time, you need to well, you see, int probably col. How can you get col? Col equal what? A R. You see, we can extract. Actually, it's not row. It's just an element. This element is an array. So we can get the length. We can just get length, right? So in that case, int c equals 0, c smaller than col, c plus plus, and then print out something like that. So probably I might have console right. So how can you access that element? That should be A, right, C. Right. So you need to check the length of each element, right? Because it's a Jekyll array. And then here, well, let me put a stop breakpoint right here. So let me show you int rows equal a dot length. Or probably you can use int rows count and dot get length. It should be does not matter at all because it is a one-dimensional array. So either way, you directly get the length. It's just one-dimensional array, right? So actually, it's just the number of rows. And otherwise, you can use the get length. They are the same. But if it is a rectangular array, you need to check each dimension one by one by calling get length function. So let's execute this line. So ARY, you see, ARY, when you have ARY, what is now? It's interesting. Oh, okay, I have not executed this line yet. Okay, done. I have executed up to this line. So ARY is a one-dimensional array. Element number is 5. The element type is int array. So when you unfold it, you see the 0 and 1, we have instantiated for 3 elements there. But for the last 3 elements, we did not allocate anything. Right now, we are about to call function g. So we came to the g right here, came to the g. So similarly, we still have a local variable. Right now it's a, right? Int rows, row count. So we like to check the length of this Jekyll array. So rows, right, equal 5 elements. So how about the get length? Row count still 5. So in this case, both of them are the same. But if you want to get length 1, definitely you will get an exception because right now rank is just 1. So you can just get length for the 0th dimension at all. All right. So that's the whole idea. So let us go back to what we have really done in our solutions array. Let me show you. So probably you remember that. I mean, let me. So in our code, we might have this kind of declaration. We have so-called, well, proper double. Or int is okay. You'll be a double arrays array, right? Okay, I just use s. It's much more easier for me to type it. So s. So we have variable names s, right? So suppose since it's a variable, so definitely there should be a storage memory for s. So suppose this is storage memory s right here. And right now we know it's a reference type. So initial value is none. Actually, there is no any 0, 0, 1, 0 information, but simply it's turned out to be none. Okay, so S is there. And then so when the code executes to a line, so-called S equal new, double, right? Maybe this time we have, well, population size, we might say, well, it's 10. Population size 10. So you need to use this statement. All right, so the element, so right now you know S is a one-dimensional array, right? And once this line is executed, oh, okay, element number is 10. But what is the data type of this element? Oh, the type is the element type the element type is a double array. You need to think in that way. 10 element. The element is double array. Okay, but anyway, so it's not double, right? If it is a double will take 8 bytes. Double size will 8 bytes. So computer need to know what kind of data, what kind of element you are talking about, because right now it's about to instantiate 10 element, right? So what is the element type? What is the memory storage requirement for this 10 element? So right now computer know now, oh, okay, your element is a double array. It's not double. If it's double, it will take 8 bytes. Since it's a double array, so it's simply for this double array, it's simply take 4 bytes. So totally there should be 40 bytes allocated on memory. All right, so computer will allocate memory somehow in a heap. For example, this type of amount. And totally, I think right now we have 10, right? So I kind of draw it. Array. So once in this memory, okay, and this point, since it's INT array, so there are 4 bytes. There are 4 bytes. For each element, take 4 bytes. Not double, right? Double should be 8 bytes. So once this memory is allocated, I mean, the memory management stuff, there is a pointer to, okay, from this point, memory can be allocated. Initially, it's right here. But for example, if the address of this initial address, for example, is 77. So once this memory has been allocated for 10 elements or double array, then the starting address will pass to S. So right now, what information stored in S is simply an address. So that is the meaning about reference data type. So meanwhile, it's almost similar to the pointer. Right now, S pointed to this memory. And then so once you use your code to access S0, I mean, this is S0, right? So array, right? Array. So S1 here, S2 right there, up to S, the last one should be nice, right? And what is the type of this element? It's not value type, right? It's a reference type because it's a double array. So initially it's none, right? So once we have completed this first layer instantiation, then we go through 4, right? I equals 0, I kind of smaller than 10, I plus plus. Because what we are going to specify the element length is the same, all the same, right? So in that case, we say Si, right? Initially is none, Si, new. Suppose our gym number or city number is 5 or 50, doesn't matter. Every row should be the same, right? So we kind of new. Excuse me. So new double. Suppose right now number of gym or number of cities is 5. Okay, everybody, every element allocate the same size of double array. So suppose it's 5. All right, so when this line is executed, computer actually use this part array. All right, so you have 5 double, right? So actually a double take 8 bytes. So 8 times 5, so 40 bytes will be used. And in order to make it look nice, I might draw another array size here. So 5 element or double. Simply, so remember that the size is not in the same scale. So right now it's 8 byte, 8 byte, 8 byte, 8 byte, 8 byte, 8 byte. Assume the starting address. I mean, for this S0, right? We are about to instantiate S0. Suppose this address may be if the address may be A01, starting from here, A01. So in this case, S0, get this guy, A01. It's a reference type. So you simply store the starting address pointed to that array. So in this case, if you want to access this element, so this element is double, so initial value should be 0, 0, 0, 0, 2. You need to go through, so how can you access that? We use this kind of notation, S0, right? So we get this 8 pointer to 1, and then the zeros, 801 zeros. If you want to access S0 and S1, so in a computer, it's just use A01, since it's 1, right? Plus 1 times 8 bytes, because it's double, take 8 bytes. So now this new address value is 809. So 800 is right here, 809, right here. So in your coding, you simply access elements through this symbol. But in fact, what computer does is that it will go to the S, 77. So right now it's the S zeros, that definitely should be 77. And then get this value. You can get the element index there. So computer finally get the value from this memory. That is what we have been doing, all right? So if you remember that last times in our GA, we have a what? We have a variable. The name is called so far the best OBJ, right? We have variable so far the best OBJ, and it's a double, right? It's a double, so it's a double, so 8 bytes allocated there. The variable right here, all right? And we also have a what? We also have a variable. We call it so far the best solution. What is the data type of so far the best solution? It's a double. Objective double, right? We have it's what? Since right now we are talking about, well, in our PSO we try to solve the continuous organization problem. So this solution is a double array. If it is the end-coordinate system, that should be INT array, right? It's an array. So remember that in the initialization, once we know the number of gym or number of city, then we instantiate, right? As you can remember, we knew double. I think the size is 5. If the city is 5 city, right there, or probably variable number is 5. So actually, we allocate memory, right, somewhere for the so far the best solution. All right. So once we execute this time, the address probably here is, for example, might be 4. Address starting address is 44. So our so far the best solution here point to this array. So the solution, the size should be the same as the solution. So later on, if we have allocate all the solution, right, we have a chunk of memory. It's similar like a rectangular array, but in fact, in computer, there is no need array concept. It's simply just a series of memory anyway. All right, but if intrinsically, this one S0 point to starting address here. S1 pointed to this one. S2 pointed to this array, right? Because each element is allocated with the same size of double array. So every guy is not. And suppose address right here. The simplest address, right? A01, A41, A81. What I'm saying is that the content of the value, because it's reference type. So what the 001 means means the address AA1 921.961 100.01 anyway, there's the address. So some address right here. For example, this one, the address 1041 9 somehow 921 there. You see, that is the data structure we have been using for our solutions. No matter it is the generic algorithm or n-column optimization or the one you are about to create today, we kind of use this kind of solutions, one-dimensional array. Each element is a one-dimensional array. So in that case, we can directly, we can say, oh, okay, this time I just use this S5 here. I simply send S5 for an objective evaluation function. So objective evaluation function get S5, right? Get this 961 information. So OBJ function, for example, OBJ function, take an here we have double array, right? Double array here, probably called S. And then the objective function can okay S0 blah 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 S can access this element, right? So what you actually pass is S, for example S5. So what you pass to here is the address 961, and this is the first element. So this function, objective function, can access this data right here, and then evaluate objective value for you. That is the whole idea. Behind this one. Okay. So once we complete all this solution construction, and we evaluate objective function, right? And then we kind of find the iteration average, find the iteration base. Saying that, oh, okay, this guy, the S5 is the best solution, iteration best solution, right? Iteration best solution. And we check the objective file or this file. Objective file is also superior than this current value. So probably current value is we try to minimize everything. So the value is 1000. But right now this is the iteration best. The objective value is 900. So we try to update. We will update the so far the best objective value with the iteration base, right? So we update this value 9, change it to 9, and then the next step is very important. Some students or your previous senior students make a wrong statement. It simply says, oh, okay, in this case, so far the better solution equal S5. What will happen? S5 is here, 961, right? So you kind of rewrite this 41, turn out to be 6961. Initially it's okay, okay. So right now S5, right? S5 here. The solution is right there, right? So probably there will be 0.1, 0.2, 0.8, some data there. So if you simply just write this one, the so far the best solution, we assign with the iteration base S5 here. So what you have actually done is that you kind of change the content of this so far the best solution. Turn out to be a copy of the S5. S5 what the value so is 961 here. So from now on, your so far the best solution is pointed to this data, this array of data. And in the next iteration, you see, we kind of rewrite everything, right? This is a draft area, so we construct a new solution right here. So your so far the best solution lost. You cannot retrieve the original one. Okay? You need to pay attention to the memory against stuff. So that is why I ask you guys, you need to, in order to, you are not going to use this statement at all. You need to call gene-wise or value-wise, one by one copy to this array, stored there. So we kind of take a range or so-called jagged array to pass one solution one by one to the solution objective function, evaluation function. But we have allocated memory for so far the better solution. You need to copy the solution one by one to this array in order to keep the right so far the better solution. So you need to know what you are doing, not just clone the code from previous students without knowing anything. It's wrong. You need to follow the instructions step by step. So in fact, behind this array stuff and this memory allocation is in this way. You need to always think in this way. So once you clear ideas, this whole concept, later on, if you go back to the C policy, you know what is the pointer really mean. But right now in C#, we kind of abstract the whole idea into reference type and value type. And you still need to pay attention to this kind of stuff. And I also mentioned that within the function, if the function is repeatedly called, do not put new statement there. Otherwise, you will eventually run out your memory. You kind of prepare a temporary array for your manipulation, for your calculation in advance. I mean, it's outside new allocate memory just one time and reuse it. Do not put new statement within a function. That function is repeatedly called. Otherwise, you will use up all the memory. Okay, so because it's dynamically running memory, the memory side of your heap memory is limited. If you repeatedly, and you call repeatedly allocate memory, then you will run out of memory. Especially those operation function repeatedly call within the iteration. You need to trim your code. If you need something to help you prepare that in advance, once, allocate memory just once, reuse it within your function, not reallocate memory in your function. All right. Okay, so that is the stuff I want to make you guys understand the structure about the array or C# program range. Is there any question? Okay, all right. So if not, we take a break. I'm sorry about the late. We'll take a break for 10 minutes. Later on, we will go back. All right. Take archive file called lab assignment 11. You can unzip it and first to take a look at the demo application. Okay. So I use broadcasting system. So what you have is a lab assignment 11. Do I have recording now? Yes. So once you unzip it, you can see there is a package, assignment 1 pack. So make sure you copy it. And another instruction is there. So it might take some time because what I gave you to is there's a benchmark bank or benchmark files. So you probably when the archive file is unzipped, it take a little more time. Okay, done. And we have instruction there for this assignment. So this assignment asks you to develop a PSO optimization system for solving continuous optimization problem. So the user might have his own automation problem, right? So user need to specify the auxiliary function, specify the number of variable, such kind of information, and also if the variable has upper and lower bound, the user need to specify that in order to make the problem modeling complete. So it involved a little bit .NET techniques. So we will ask the user specify their function, auxiliary function in C# programming language or in VB.NET programming language. And later on, we take the source code or the function definition and then somehow compile it in runtime. And then combine it with your solver, your executable file, or your DLL file. Then we solve the problem in machine code. It's a little bit different from the using Excel, right? In Excel, usually you can specify an equation, complicated equation on the on Excel, right? And Excel do pass that equation in their own way in order to evaluate the value of that function, right? That is the method or techniques provided by the Excel. But right now, I kind of hide these techniques within a file scope. But again, the user, if the user want to set up its own automation problem, continuous problem, user need to get familiar with C# programming language. So later I will show you what this problem file, what this benchmark file, the format of this file stand for. Later on I will show you. So basically you are asked to develop a PSO automation system, right, to solve. So by default, PSO is suitable for solving continuous automation problem, which means that the variable are real number. And usually we will have upper bound, lower bound specified for that. Otherwise, the real number might have no any limits at all. So which means that the value range can be start from minus infinity up to positive infinity. This is also possible anyway. But in fact, that means in coding, you should definitely have a maximum value, right? Should have a maximum value acceptable by the code. So we ask the user provide this information. And again, for this assignment, you were given a DL prepared by me, by our lab. Okay, so I will show you how to use this DL to show, to read in a COP benchmark file, and then show the graphics information about this problem on WinForm application. So I will instruct you how to do that. And what you need to do is that you design a class, PSO solve class, solve that benchmark problem selected by the user. So that is the whole purpose. So let us study about the continuous automation problem a little bit. So basically, one model of continuous automation is that at least you need to contain this kind of information. The first one should be the dimension, right? That means the number of variables within your automation problem. Okay, so possible PSO GA, I'm going to encode it. So the PSO can directly encode this automation problem as a list. Actually, it's a one-dimensional array of double value, right? So an array of double value should stand for a solution. So if we use the mathematical notation, its axis, you can treat it as a vector, start from x sub 0 up to x sub n minus 1. Following the C family indexing convention, we start from 0, right? But mathematical wise, probably you denoted that start from x sub 1 up to x sub n. It's up to you, but actually just the indexing stuff. So for each variable, we ask the user to supply the lower bound and upper bound because it's a real number. So we ask a lower L sub I, which means that the lower bound of the variable x sub I in that way. So x sub I is the real value, so as components of your solution, lower bound, upper bound. And user need to provide an objective function, and especially whether it is a minimization or maximization problem on this objective function. F function is defined by the user. Okay, so later we will go back to this benchmark later. So let us just run the demo application. I mean, to see what the application you are asked to develop look like. Okay, so assignment 11 pack. Within this pack, you can see there is a COP bank, I mean benchmark file in the format we specify in our lab, right? So COP bank contain probably, well, maybe 70 benchmark. I cannot remember the exact number, probably at least 550, right? So each benchmark will contain two files, consists of two files. One is RTF, rich text format file. Well, as you can remember, we have a rich text box, right, in WinForm application. So you can specify any RTF file, and then we can put this file, the content of this file, into our rich text box nicely, easily. And for a benchmark problem, definitely there should be a specification about the objective function, right? So objective function will be specified within .co file. So if you take a look at a .co file, so drag one COP file in it. You see this file is formatted, right? This format is purely developed by the instructor, by our lab, okay? So we have a title column, so it's a string, accurate, okay? And the parenthesis, there is a number indicated there, which means that the dimension of this continuous automation problem. Two means variable just two. The variable just have x, y there. So it's a two-dimensional automation problem. Type, minimization or maximization. Dimension here, two. So you can choose the file name knowing that the size of the problem. See, most of these benchmark are two-dimensional problem, but some of them have 30 higher dimensions. 30 means that one solution consists of 30 real number. All right, so you can perceive the complexity of that problem from the file name anyway. So since the dimension is two, right? There are two variables. So how about lower bound and upper bound? Sometimes all the variables share the same upper bound and lower bound, and then by that case you don't need to specify the lower bound or upper bound for each variable at all. But right now, if the specification type is enumerate, you need to enumerate the lower bound, upper bound for each variable one by one. Each variable will take one row. I cannot remember, probably the bound should share all the same. Otherwise, I cannot remember the keyword you should specify here. Never mind. The time our DL will have a function facilitate the user to create a COP problem. I mean, in this kind of format. If I have time, I will explain that to you. All right. So usually a problem might have a single global optima, right? But some other cases, some other benchmark might have multiple optima solution in different kind of location, but the objective value are the same. So in that case, you might have multiple optima solution with the same objective value, but different solution. All right. So number of optima solution is one, and this solution is right here, showed up here. If more than one, then you will see more row appear in this file format. So best objective value, right? This is the global best objective value. Number of linking data assembly, well, it's used by our code. If you kind of prepare a DLL, specify the problem in advance for us, we can directly use that. So usually you don't need to bother about that. So basically you don't need to bother about create this benchmark file by yourself, right? So we provide a user interface for the user to simply type a C# code there, and then we will prepare this file by our application anyway, somehow. So coding language is C#. The another option is VB.NET. Visual Basic language is still acceptable. So similar to a design of C# class, we have global definition. We have initializing function, so you can specify variable, which is purely used by yourself. So you can define it there, and you can initialize those variables too. But most importantly, you need to provide this puzzle code, auxiliary function. The tag is auxiliary function. So basically, this code is a C# programming language code, following the format we have specified. So this function, you will give the solution, right? Solution always in terms of x array. So presumably x0 should be the first variable, x0, x1 up to there. So you can feel free to define any local variable. You simply treat that as a function. So you are write contents of the function all by yourself. So you can add a local variable as many as you wish. And the purpose that you need to specify the value of objective. Objective is a variable predefined by our format. So eventually you evaluate the objective value somehow. And you still can use the same C# programming language math, right? Math is a class defined in the .NET framework. So basically this part is a source code of C# programming language. So if you are a new user, you need to specify your own objective function. You need to prepare this code somehow within this objective function block. That's it. And if your objective, your problem, the objective function can be differentiable, and you can provide gradient function right here. Hard computing optimization techniques usually need gradient information, but not for our meta-heuristic algorithm. We don't need that. But the only things you need to provide auxiliary evaluation function only. So if this benchmark provide gradient function, then this problem can be solved by hard computing method. All right, but for our PSO, we don't need to use any gradient information at all. So if you would like to specialize gradient function, you need to still follow some kind of rule we pre-described before, in our file format. So never mind each benchmark right now. What you get is a bunch of readily used benchmark file here. So each file will have. And how about RTF file? When you double click on a RTF file, you can see word will be invoked, or otherwise you can use WordPad too. Okay. Okay. So I think we like to see, right? This equation. The word by default right now is so probably I cannot see it. See the graphics right here. So a bunch of equations have been added in RTF file. By default you cannot see it. So let me try use WordPad to open that file to see if it is okay or not. Benchmark should be right here. So drag an RTF file to WordPad. Where is the WordPad? This is Word. WordPad right here. Okay, as you can see, it's an RTF file. So RTF file is not plain text, right? So actually, in RTF we can add an object. So this is the equation object, right? Equation object. And also we can add graphics, image picture. This is equation. So this kind of format is called rich text format. So in associated with the COP file, there is an RTF file to provide more readable information associated with this benchmark for the user to read through everything. So our library can show the content of RTF in a rich text box, and read in the alternative function definition, which is in terms of C# source code, and then compile those alternative function evaluation code into executable code and link with your solver together, so you can solve your problem. In machine language label. All right, this is the whole idea. So what you get is a folder containing several readily used benchmark there. And I also provide you a demo application, demo PSO for solving COP. And DLS is a dynamic linear libraries I provided to you in order to directly access COP benchmark, which is similar to the TSV benchmark that you have done before, in last assignment. So let us run the executable demo application first. And within this demo application and the application you are about to develop, you will be asked to use the T-chart again, because we like to see some visual display to learn the meta-heuristic algorithm, learn the progress of using meta-heuristic algorithm, the efficiency of using meta-heuristic algorithm to solve two-dimensional automation problem. So in that case, all right. So this is a simple application. Right now we have a Microsoft chart ready for evolve our solution, best solution so far. Right. So usually we have iteration average, iteration best, and so on the best too. And remember that I did not ask you to implement the real number encoded GA. If you are enthusiastic, you can implement continuous encoded GA by yourself, because we have a very well established the object-oriented structure there. So you can follow the similar operation you carry out in developing permutation GA or by yourself. So once you finish the real number GA, you can use that your GA library here to solve the continuous automation problem too. Okay. All right. So in your application, you might prepare, for example, there's a panel right here, right? And there's also another pages, right? Pages is another kind of panel. So once you open the benchmark, so we navigate to assignment 11 pack, right? CLP bank, this folder. So we check out the peak. Peak is two-dimensional. So you simply click on CLP file, will be okay. So the program, the DL give it to you, will search the same folder to check whether there is a peak to an RTF file. Now actually we have, okay. So actually we have everything right here. We have in addition to a CLP file, there is a file peak. So we have peak to CLP peak RTF. So you simply click on CLP file, will be okay. Our code will search RTF file too, and then display RTF file here. You see, this is the rich text path file, right? We just see it. This is rich text path file, right? Okay, this is the equation objects written in equation by equation application, and we also can see the figure displayed in a rich text file. So rich text file content put in here. And then the information about this problem showed on this user interface. So title is big 2, minimization, not maximization, not low. Dimension is 2, just 2 variable. Upper bound, lower bound specify the user, right? So we kind of display this information right here in this user interface. Number of known optimal solution. Some problems have multiple optimal solutions, but they should be the same. The objective value should be the same. So objective best objective value is -6.55. Okay, all right. So once you open the benchmark, your application can prepare a panel. Our DLL will instantiate the user interface for you to let you display the contents of this benchmark in this panel. How about the solution surface? I mean, the solution function. If the problem is two-dimensional, definitely it will use these two dimensions to serve as x, y axis, and then show up the objective value along this surface. So this three-dimensional surface display is simply for you to investigate the improvement of your solution. Okay, so this chart, as you can remember, is a T-chart. It's not Microsoft chart. Microsoft does not provide any three-dimensional graphics capability. Since right now we have two variables right now, so since it's three-dimensional, so actually what you can do is just choose two dimensions to serve as the x, y. If your problem is a higher dimensional, for example, three-dimensional, and what you still can show a three-dimensional surface, but you need to select any two different axes there. But it's meaningless at all. But for this graphics display, it's only suitable for two-dimensional problem. But again, you still can use this graphics display to show projected objective function on two coordinate arbitrary set level. So you can set up the resolution right here. So all this stuff you don't need to bother the coding by yourself. Our DLL has prepared this functionality for you. What you need to do is that prepare a panel, then show that. Solution information right here. All right, so we have ready in the problem, right? So we are about to instantiate a solver or PSO or solver or GA. It's up to you. So try to think about the public user interface function need. We will instantiate with a new, right? New an object, and we have prepared a property grid for the user to specify the property. So if you really go through the PSO slide or video, then you know for a PSO solver, user can specify the coefficient, right? The congregation factor, self-congregation factor, the other should be social factor. Actually, it serves as a weight, a kind of weight, to in order to generate the next move. Number of particles, which can be specified by the user, right? User probably might deploy 100 particle to serve as a 100 solution agent, try to search so far the better solution for himself anyway. So its stopping condition right now is so simple, just iteration limit. Once the iteration count reaches this limit, then the solution evolution stop. Right. So similar to the GA and SEO, we should let the user change the parameter, right? And once the parameter has been changed, we provide a function reset everything, prepare memory for the new population, right? So reset is always required. As users can click on reset to reset all the data before executing another round of solution evolution. So one more iteration. You see, right now we have 10 particles, and this problem is two-dimensional. So you can see the current solution displayed as a point, right? Each solution just have x, y coordinate value, right? So you can see currently the 10 particle the location right here. And this automation problem is very interesting. You see, we just have global optima right here. The value is minus 6.55. Take a look at this solution observation function. You can see there is local minima right here. This one is local minima. Another local minima is there. So if you are using a hard computing method, if you specify the initial solution right here, then it will quickly converge to local optima, not a global optima. I mean, if you have a solver, hard computing solver, you can try that by yourself, okay? All right, so we kind of monitoring the description of our current particle right here through this figure. So once I finish a step, as you can see, the current observed value is -3. It's not the global optima yet. So this I think that should be this point, -3.3. So you can check the movements of your particle through this graphics display. Help us to know the effectiveness of your method. So what I'm doing is the PSO method. How about the next iteration? See, we keep monitoring so far the best objective value right now. So it's -3.9. Next iteration, drop to 5.5. So you can check it right now. The solution kind of converges to the global optima somehow. All right, so run second iteration, another iteration, another iteration, another iteration. All right, so we let it run to end, run to the iteration count reach the limit. So that is the behavior of particle song optimization. See, some particles still struggling, try to find a better solution, but the rest of the solution has been converged to this point. Is it the real global optima solution? Not quite. See, it converged to somehow this point. There is no any further movement at all. So what we get is 5.7, right? But the global optima is 6.5. So it is still not a global optima yet. So user might change these two, factor, social factor. So probably I kind of increase congregation factor, which user might change 0.7. And user might change the number of particles into, well, I kind of employ 20 particles to search a solution for me. Okay, so I reset. So reset function will accept the newly set parameter value in order to allocate memory for the solution evolution, right? So reset everything. So right now I have employed 20 particles. So again, one iteration, and then I run to end. So I think probably within iteration, maybe 19 or 20, probably, I don't know. We have reached this value, -6.551. It's close to the global optimal solution. Yeah, we also need to check XY coordinate 0.230. Still, it's not exactly the same as the location of the global solution, but it is close. It's pretty much close. So that is the performance of PSO. How about GA? If you have GA, you can check the behavior. So create solver, create a GA solver. GA will have different kind of parameter, right? Attribute, a property to the user specify. So iteration number. So I like to compare the effectiveness of these two methods, right? So I use the same iteration limit, 100, and probability size 20. It's 20 particle too. Okay. So I use deterministic selection method, right? So this kind of fact, the property you are familiar with. If you implement the binary and the permutation GA, they are all the same, right? But since it's a real number encoded, so we will have different kind of crossover type of specification. Convex or large divider. You can check the slide. I have to talk about the definition of this crossover type there. Okay, number of cuts probably just one cut. So half of them will be updated value. So similar. So right now I use GS over reset, long one iteration, similar, right? So all the meta-heuristic algorithms share the similar operation. All right. So this is GA 20 chromosome. One iteration. So you can check the description of this 20 solution somehow. It's a little bit different from the PSO, right? PSO quickly converges to 1 point. I do see some students still does not have you might concentrate on what I'm talking, what I'm showing, alright? I don't know. Maybe you can do it by yourself, okay? Forget it. So I run it to the end. It look like weird. I think we kind of still have the previous point, especially there. So what if we have 6.4? So we reset everything. I think we might screw up something there. So PSO particle still remain here, right? So let me restart it again. So it might be a bug, okay? Or probably that is a responsibility of your code. You need to erase that. Show the peak again. This time I already use GA, create solver. So by default, 20 chromosome, 200 iteration limit. So reset, once you reset, 2, 4, 6, okay, 20 point. One iteration. They run to end. So check the progress of so far the basis solution. See, they quickly converge. Well, we don't know whether this point is local optima or global optima. And then from that time, stay still, right? Stay still. So check the solution we get, 6.551 is exactly, means pretty close anyway to the global objective value, right? How about the solution? 2.22282, right? 83. So it's almost exactly the same as the global optima. So we have this kind of power. But again, this benchmark is trivial because it's 2-dimensional, right? But usually our benchmark might have high dimensions. For example, actually 30. So that means variable. We have 30 variables. See, so low bound up to 30 variable. We have 30 variable. Dimension 30. So right now it's meaningless. I mean, if you take a look at this figure, it's useless. It's meaningless at all because it's just projection. Solution function is 30 dimensional, but right now we just project on 2 dimension. The dimension you can arbitrarily select one, okay, refresh it, but I think there's not much difference. All right, so we create particle swarm solver, we start it, run to end. It's okay because it's useless. I mean, it's meaningless at all. Okay, so you just don't say you are not going to say, well, it's far from the global optima anyway. But probably from certain kind of projection, it's close. I don't know, but you need to check the value somehow. So we know there's just one global optima solution. The solution, the position, the location is the coordinate. All 30 coordinates are 0, exactly 0. That means the global optima is just located within the center of this area. So what value we get? Our objective value is 14.3, far from the objective value is 0. See, 0 is right here. So for higher dimension, PSO does not perform well at all, right? We can say that because initial objective is 20, and then we stuck out on this 15. But probably you can change something. So maybe this time I change it, the coefficient, the concatenation coefficient is 0.8. We set everything round to n again to see if it is improved or not, but it's not guaranteed. So again, we're still far from the global optimal solution. All right, this is the behavior. We can check the distribution of this well, okay. So let me increase 20 particle, and then probably iteration limit 200. Reset everything. Try to run it round to end. See, you see, all the particle quickly converge to the same point without any further improvement, right? So it's a characteristic of particle sum optimization problem in solving continuous error. But how about the GA? So right now, you remember that's what we get for this problem is about 15. So we can try GA, reset. Similar, right? We have 20 chromosome, 200 iteration, reset everything, run to end. Check the progress of global objective value. You see, this is very important. In this case, which means that our algorithm is still alive, right? Try to keep reducing the so on the best way. So you see, this is the GS performance. We get the local element smaller than the PSO, right? We have reached 5.11. So in this case, if I increase population size into 50, reset, long to end. So for soft computing method, for especially meta-user algorithm, we know we have a bunch of parameters. And there is only certain rule saying that what kind of parameter you should set, what kind of parameter you should set, and then you can get the global optima. You need to try that. I mean, try several times, and then theoretically you can use so-called experimental design method. For example, Takeuchi method. Try to find out the inference of this variable. Try to find the most important factor somehow through experiment design techniques to do that. But usually you need to try different kind of combination of this variable in order to get a better solution. All right. So from this viewpoint, for higher dimensions optimization problem, PSO is not promising at all. PSO can quickly converge to global for simple problem. All right, so this is the demo problems we have. Okay, so next step I will show you how to use the DLL that I gave it to you, for example, to open a benchmark and show the property there. And later on, your PSO might need to access objective evaluation function, right? So I will show you how to do that. Okay, is there any problem about this demo? Okay, all right, so we start our assignment, all right? So check the pack I gave it to you. We have a DLL subfolder and COP bank for you. So you have better, and let's move this you don't need to move the COP bank into your solution folder because this file is so large. I think the size is pretty large. But you definitely need to move DLS into your project. So, okay, start the skeleton. I'm not going to show you all the details. You need to implement the solver by yourself. But for the benchmark access, I need to show you how to use the DLL. Okay, so Visual C# desktop, WinPhone application, desktop. So you guys are right 07. 5000. Assignment 11, PSO. Alright, so everything is already there. So Visual Studio will prepare a solution folder for you, and then we needed to modify the file name. Also, the form class name. And Okay. So we have graphics user interface, right here, and then okay, let me quickly just do the simplest layout menu strip, right? We have menu strip, we have tool strip, we have status strip. Oops, excuse me, right here. Tool strip. We have status strip, and usually we have a split container. It's too large. And my Windows resolution is not so much. So split container. And later on, probably you need to SSH, so you had better change the actual name, split container 1. And this is my commission, SPC split container main. Somehow, there. And probably within your panel 2, you might have tab, or I don't know, tab. You can check the demo application, tab control. Show you tab control. And remember that we have pages, right? So it's pages. It's a tab control 1. It's a page. PAG probably is display. GIPHI graphs DISP area display. Okay, so remember that panel 1 is panel. Panel 2 is panel. Again, the page in a page tab controller is another kind of panel, so they can host others control. So we have a button, tool strip button, tool strip button. It's open, right? Open. And face text open, that meaning there will be a dialog shown up, and the image display style, or just display style, not just image, including the text. All right, so we will subscribe it, and then later on. So before that, we will use the DLL provided by our lab. So you find the solution right here. This is solution. So move the DLL in it. And I ask you just put a DLL on. Don't drag the whole COP bank in your solution, okay? Otherwise, if I check out your assignment, I run out a lot of time to decompress the COP. So don't put COP bank within it. Probably you move the COP bank into your desktop. Later on, you can try that benchmark easily to allocate. So we have DLL ready, right? So let's take a look at DLL. DLL including a COP benchmark DLL, right? So another file is called XML. XML is just a helping file. And this all the function explanation somehow has been defined in XML file. And this time, the COP benchmark needed the help of tchart. So tchart will be used by the COP benchmark. So you need to include all this thing here. But I think it's probably what you need to include just the COP benchmark DLL will be enough. All right? Okay, so we have DLL here, ready, right, in our solution folder. So right now we are about to use it. So go to the solution manager right here, references, this category. All right, so it's static dynamic DLL there. It is not a project. Okay, so we since add reference, and then we browse it, right? Browse to that's right. So up to desktop, 11 PSO here, DLL there, I think it's probably you need to choose reference, probably just COP. I don't know if it is not okay, then you will add another reference to the t-chart too. So COP benchmark here, add it. Okay, make sure. So right now we have COP benchmark ready. So it is a dynamic link library provided by Lambda. So let us take a look at this contents of this DLL. So COP, continuous automation problem benchmark. Click COP. There is a namespace called COP, right? All right. So we have a class COP benchmark class. We have objective value display. We have COP problem display. Objective should be graphics display. Problem display. We also have a problem editor, and we have two enumeration automation type, programming language, whether it's C# or C# or Visual Basic, automation type of minimization global. Okay, so that are the class and the enumeration special within this DLL. So let us take a look at the COP benchmark. The block in purple color is a function, right? Constructor COP benchmark constructor. So we need to instantiate an object of COP benchmark. All right. Create a new problem and show edit. Well, it's a function you can try that. Display a problem on panel. Display a problem on panel. So what you need to supply is a benchmark and a panel. Right? Display objectively graphics. What you need to supply is a panel. Oh, okay, so why we will use that? And display objectively graphics over problem. Display objectively graphics over problem. Well, once you are wondering what this function is for, well, you can check the display, the help information there. Okay, I think the comment has been added here. In verbose style, so we can check that. Display a solution, and I think the most important is that we will locate the function, right? The function compute objective value, right? So display solution, get gradient, get objective value. Oh, right here, get the function get objective value. So in your PS solver, similar to the ACO and the GA, you will define a delegate, right? A delegate function delegate. This is delegate right now is simple. Just take a double array, return double. So in that case, you can assign this function as a parameter to construct an object of your PSO solver. All right. So this function, which is similar to the TSP benchmark problem that compute the object value like that. So that is what you need. What I just mentioned before is that you can edit it somehow. So if you like, you can show edit it somehow. If you get the object or COP benchmark, you can do all these things. And the property is right here, best objective value. So you can get the best objective value right here. You don't need to prepare your own one, all right? So somehow you can check the explanation of this property there. So okay, never mind. So right now we know we have COP benchmark class later there. Display, I think it's control. Somehow it's control. Probably I will show you if we have time. But right now, the information we know is right here. Okay, so we have open, right? Open. Then we will now form. We will have. We need to include that namespace, right? And so we know we will have the benchmark. That should be the object, which is not similar to the TSP. Okay, in TSP we simply use that class name. Okay, because everything is static. But right now you need to instantiate an object for the TSP benchmark, for the COP benchmark. Okay, COP BEN CHM. Well, let me use an namespace by the code using C. See, there's a COP namespace there. Is there anything? No, I think it's just COP will be enough. So using COP, then I can type COP No. I'm sorry, I typed in wrong place. Let's put it here. COP. See? IntelliSense has identified that there is a class here. So COP benchmark. I will call it a problem. Okay, so we have a problem. And I think I might just instruct you one step further. So what do you need to do it by yourself? That well, you need to add a class. So this time I will call it. You should name it by yourself, okay? So here PSO solver, COP PSO COP solver class. You need to do the design all by yourself, okay? I'm not going to show you this. Just refer to the generic algorithm and SEO method. Do it by yourself. But in your user interface, definitely I will have a PSO solver, right? The solver. So you see, the main function just serves as a user interface. I recruit a solver. I ready in an object or a problem, and then go between them. Make sure they can read each other. So definitely the solver should the constructor of the solver needed to have a function pointer, right? So the function pointer should be came out from this problem. So the first thing is that you need to instantiate the benchmark problem, the object of the benchmark problem first. So we solved the dialog, right? So we were file open dialog. I don't know problem, I don't need it. So let me try it. So I subscribe the click event on this button, subscribe this here. Either way, double click it, or right here, double click it. So subscribe this form open. Let me try that. Okay, probably is I can just use the PSO COP benchmark. Let us check if there any static function can help us create an object for the COP problem for us. Yes, we have. So you see, what I'm doing is that I directly use the class name, try to access static function, and read that one by one. Create a new problem. Display load. Okay, right here. Load a problem from a file. So from a file. Okay, from a file. Show edit. So never mind. I just simply invoke it. Let IntelliSense show up the instruction here. So pop up a file open dialog to open info file. Then read the file to create a problem. See? So when this function is read, is executed, I get a COP benchmark problem object ready. Okay, I like it. And this overloaded function, so I check out the second one. The second one, if I do have a file path ready, I invoke this overloaded function. But no, I do not have a file name. I will ask it, you will load a program to pop out the dialog open dialog function dialog for me. I'm not going to prepare that by myself. So okay, it's it. So once I load the file, then I assign to the problem. Right? So it's here. So let me set a breakpoint right here. So step by step wise. Open. See, I did not do anything, right? So I did not add any dialog at all. But once I execute it, so I hit F10. See, this dialog is pop up by the DLL file, not by me. Okay. So open a COP problem definition file for a continuous automation problem. So kind of navigate it to desktop, right? COP bank. All right. So this time I open peak, the one peak I mentioned before. Open it. COP open it. So right now the problem is ready. See, the problem is ready. So everything is right here. You see the based on the benchmark has this kind of information. minus 6.55 such a function there, and including their source code, right? Gradient combination, objective value evaluation. These are the source code written in C# programming language. So okay, everything is there. But right now we like to display it, right? Display the information. So how can we do that? So from this step, right now you have object ready, so you try to access the functionality of the object, the problem. Check what kind of function you can have. Display an objective graphics. Whoa, okay. Panel, what do you need to program? So we will display objective graphic. Display on panel. Display a user control listing property or COB on a selected panel. Well, this is probably what I want. So, where should I put it? Well, we have what? We have panel 1, right? So we ask SPC container, specimen, right? SPC container, panel 1. Yes, panel 1 to show it. That's it. And we also have what? We also need the problem display objective graphics. Wow, it's powerful, right? So again, what it asks is just a panel, the host, right? So remember, where is it? We have page, PAG, class display, right? We have PAG, we specify the name. Remember that we specify the name where? This page, this panel. So we have to display the content there. Okay, so let us run it again. Open, execute it. Peek to open. Alright, bingo, everything has been prepared for you there. See? Panel display right here, but you need to have enough space, right? So you need to use anchor or dock. Otherwise you get a small, everything has been squeezed within this area, so it's really troublesome. So you see, we can have this function ready for you there. Okay, that's it. The next step is that probably for example, you might have a button somewhere. So in this case, I simply set anchor or probably dock. It will be okay. Speak container, right? Dock field. So I will not worry about that. But again, I think we still need another one, so I'm not going to do that. Simply set not. Instead, I set anchor somehow. Set anchor, right? So you need to design your own user interface layout, okay, by yourself. And probably we will have. So you need to do that. I mean, by using Speak Container to get a better layout. Right, so we might have property grid, right? Property grid. Property grid. For what? For solver, right? So this kind of the name probably solver is a solver, right? And reset. Similar. Try to think about what kind of popular function you should provide in your PSO solver. Reset, right? Run one iteration, right? It's almost these two. And you should define a lot of user modifiable and editable property within this property grid to let the user specify. At least you should have iteration limit, right? For PSO, it's very simple, just two users specified parameters. One is a combination factor, the other should be the social factor. So you need to provide there. But right now, the problem is how can we bridge them together, a solver and the problem, right? So usually in your solver, you need to have your constructor, right? CTOR constructor. And you will ask the user to supply enough information for you. So probably you will ask what? Int number of variable, right? And another one is what? Number of variable. Well, minimization or optimization type, right? So probably you might define by your own. You might have a public. We better set everything's public, okay? Because PUBIC public. You might have a new. We keep defining this guy, right? Optimization type. Minimization, maximization, right? Maximization, minimization, right? And in addition to this enumeration, we also needed to define a delegate. And this function is return double, right? And we might call it function. All right, never mind, just objective function. Take a double array. Do I need a name? Probably not. No, need a name. Okay, never mind. Solution. Okay, so we have delegate probably. All right, so you ask that user need to provide an optimization type. DYP. And you also ask the users to provide an delegate. OBJEC objective function, right? OBJ func. Okay, so you design it, and if a user want to use it, user need to provide this information. I don't know whether this information are enough or not. You design it by yourself. Okay, now. All right, so what I'm going to show you is that, okay, once everything is ready, we create a PSO, right? You create a PSO, so you are about to instantiate this guy, right? The solver. You are main phone. You serve as a user interface. You have a problem ready by right now, and then you need to instantiate solver, right? So the solver, new. Okay, this is the only one instructor provided by this class. So how can you get a number of variable? Do I need a variable special in the main phone? No, because every problem has been stored in this problem once the problem is ready. Okay, so you need to make a full fault proof. The bottom one initially will not be quitable. The inability should be disabled, right? Because we need to we need to construct the problem first, and then we construct the solver. So this button is not going to, you need to make this button disabled. You need to pay attention to this kind of fault proofs mechanism, right? Okay, so back to here again. So where is the number of variable? Well, I'll try to access the problem. Do I have a property number? I don't know. Number of variable? No. The problem. Dimension. Sorry about that. So we call it dimension. It's a COP problem. The number of real number variables in the specified problem. Okay, this guy. So everything has been stored in the problem. How about the second one? The type, right? Minimization or optimization type. Well, again, if you are not sure, but for this problem, you know it's minimization, but probably we should check the problem. Optimization type, optimization goal. Okay, it's called optimization goal. Optimization goal is a COP optimization type. So you see, the library itself has its enumeration, right? It's enumeration. So we need to check the problem optimization goal is equal COP that automation type that maximization. We check whether it is maximization. Then we return optimization type that maximize. Otherwise, because what we have in our mind is just either it is maximization or minimization. Okay, so the second argument is right here. So probably you might, well, in this case, the code is kind of messy, so probably you should prepare a local map. Probably you should have optimization type TP somehow. And if the problem that optimization goal is exactly equal COP optimization type maximization, then ty equal optimization maximization, else ty equal optimization type minimization. So you still can do that in advance, prepare a local variable. So in that case, the construct invocation will be much simple, ty, right? Ty, because the second argument is automation type. So remember that automation type is defined by you, by your PS solver right here. This type is defined by you. Okay, so you ask the user to give you this kind of information. But what we have is that the problem has this kind of information specialized in different kind of type. It's called COP optimization type. Well, so far the name is exactly the same. Probably I should change it. All right, so probably in my benchmark, all right, I might call it, rename it, my OP type. Anyway, you can feel free to change it. See, once I rename it, my OP type, it's minimization, maximization, my OP type. So back to your main form. Oh, okay, I prepare a lot of my OP type. And I check the information stored in the problem, so I can do that the same thing. So how about the third parameter? It's a delegate objective function. So we can check whether the problem get objective value. We will check whether this function, you see this function get objective value. It's okay. I mean, it's params. That means the argument can be supplied one by one. So get objective value. If they only component from the compiler, definitely it work. Okay. So the solver constructor. And I think that's all. Probably that will be all, right? I mean, what's left should be done in the PSO solver. PSO knowing that with the dimension, so you will allocate the number of variable of their solution right by themselves there. And I think the problem what's left should be the display of the function. Okay, so display the function. So how can we do that? So let me show you. So if we want to check the solution, right? You see, I mean, in the display, what we have in this figure, right, we try to plot the point, right? Try to draw the solution. Those solution has been stored in where? Stored in the solver, not here, right? Not in the form, and not in the problem. The solution, the point of solution has been stored in the problem. So how can we display the solution in the solver to the T chart here? So let me think about that. Think about that before. So we should. Do we have another one? Let me think about that. So let me check about the problem. The problem display objective graph display solution. Okay, this function display solutions on graphics. So what we need is a solution. See, the argument is solution. Solution is from solution. Where is solution? So you need to provide the solution. All right. So okay. So in order to let your solution or your PS solver displayable on the T chart. You see, our solution, right? So we will prepare a solution right here. Double, right? Because it's for COP, right? So double array solutions. It's private. It's private, but user might want to access it. So we have public property. Double. Capitalize, so SOLUTI solutions. And it's read only, so it's get. We simply return solutions back to the caller. And it is not browsable, right? It is not a parameter or a software. So we will use this BROWSER, browsable, false. And then the IntelliSense added this using statement for us, component models, browsable, false. So we have a solution there. It's public. So later on, if you want to display the solution on graphics, you can directly ask the solver, the solutions. Okay, so we try to do it. Let's try to do it a little bit. We'll try to complete this code to show you whether this code is working or not. Solver here, right? Solver here. So once we construct it, I kind of initialize int number or part, yeah, TIC is number of particles, probably 10. Okay. So your code is not going to like this one. What I'm going to show is that where can I display the last solution right on the graph. So now I just want to make sure it's okay. So actually you are not doing it in this way. So in the construct the solution, new double, see, level by level, numbers of particle, number of variable, number of particles, right? So the element is the int array, double array, excuse me, double array. Then for int I equal I smaller than number of particles, I plus plus, then solutions, I instantiate new double. How about the size? It's number of variables, right? And in order to show something, so I keep a specialized initial value randomly. Okay, so I need a random number generator IND new. So once I get it, get number of solution, get it, so I can for int j equals 0, j smaller than number of variables, j plus plus. Then solution, see, right now I want to access this array, the j's element equal RND next double, right? Next double. So actually, this function should be amazing. Oh, okay, not just this. It's not enough. We need to know. I'm sorry, the constructor is not enough because for the PS solver, try to initialize the initial solution, right? The PS solver needed to know the upper and the lower bound of each variable. So in addition to this number of variable, the PS solver would ask about what? About double array, lower bound. And also double upper bounds, right? So you name it, you ask it in your constructor. So a user, if you want to instantiate your class, the user need to follow this requirement. See? So actually what we have is here. If I have low bound, upper bound, I can arbitrarily set up a value right here, right? Okay, so I will make it much more complete. So that should be the low bound. Well, actually, I just prepare a function, void. I prepare a function, and I call it. It's much more elegant here. So I call it randomly initialized solution. Number of variables. So I need a number of variable. Int exactly the same name. So since the name exactly the same as the constructor, so I needed to use this, that number of variable assigned with the local variable number of variable. So number of variable already. Then so I will use, oh, not just that, we also needed to have a lower bound, upper bound, right? So, well, double lower UNDS. So this lower bounds equal lower bounds. This upper bounds equal upper bounds. What's wrong? Did I spell you right? Lower, I had better copy and paste it. Okay. Alright, so I keep using lower bounds right now. I will start from this point, I will use lower bounds. The J's lower bounds, right? Plus random number double times upper bounds, J's upper bounds minus lower bounds. Okay, I think that's it. So lower bounds random number generated there. So I will randomly assign. So once this constructor is complete, then definitely this PS solver has a solution, initial solution really there. So I can try to display it somehow. So okay, so back to our constructor right here. So right now, we need to provide more information. See, the first is dimension. Then we need to have lower bound. Do we have that? All right, check about the problem, lower bound, right? The problem. Yes, we do have lower bound, right? It's exactly as the same type, double array there. So we give it the problem lower bound, the problem's upper bound. Yeah, we added these two. So probably, well, you might think, well, why we make it such kind of troublesome task? I mean, we add a lot of parameter there. Why not we just give it the problem? It's okay. It's another solve. Okay, it's you solve, but in that case, your solver it's tightly binded with the problem of my DLL. Okay, so again, that is another kind of thinking. So in that case, your solver will depend on the benchmark of my DLL. You should always carry DLL with your solver, which is, programming, object-wise, is not good at all, right? So we let the solver simply solve general problem. Once it is a COP problem, it is not tightly tied with the my DLL. Okay, so that is much better. So in this way, it's much better. So we stage a solver to solve this benchmark. So display solution on the graph. Yeah. So let us think, check about whether it's okay or not. Quick one, solution, display, button one. Once the solver is ready, we'll display it. All right. So let's see what will happen. open. So we let it go through. So suppose I show peak to here. So I enlarge, use up all the screen. You see what's wrong? What's wrong with this guy? Because it's anchored to the left and top. So it's not okay, right? If it's not okay, so you need to always enlarge your screen, okay? Some of you still, I just kind of do it to score you, but you should follow what I'm teaching you, using anchor, using dock to fully utilize the space of screen. So you should always, click on this guy, click on this button, enlarge your application to see is there any waste or screen space, or is there any control light up, and then adjust their anchor and adjust their dock property to have a good user interface in there. So right now I simply, because I did not add a split container here. So what I'm going to use, just anchor this right hand side, this guy's right hand side into the right. Okay, because this is the most important control. So kind of anchor this guy, right? And in the right to the for the control to its right, I need to anchor these guys. The anchor should be anchored to right. Otherwise, they will be overlapped. So anchor right. So this is the only change I have. So as you can see, if I enlarge the windows, these guys keep expanding. But since this control anchor to the right, so it's okay. You just move with that. So if I we can do it right. It's okay. It will look okay. All right. So peak here. Whatever showing up here, right? So right now we do not have a solution showing up right here, right? But this series has been ready there. See, has been ready there. So in my material, I have to prepare this graphics display for you. So I create a PSO. See, point has been shown up right here. All right. So 10 point, right? So design your PSO, design the property right here. So use my change proper provision change to 20, and then reset it. Then the whole thing will be displayed again. So I think it probably these are the function defined within the benchmark you are going to bother about. So we have see this function display solution on graphics. So you simply provide a solution. So if you need to update the solution, you simply invoke this function. Okay, is there any question? I think that will be all I instruct you the usage of this DLL. What step should be your own design on your particular swamp solver? So you need to define, well, actually I think the public user interface are almost reset, run one step, that would be enough, right? And then you need to prepare another user interface, prepare another Microsoft chart to display the so far the best objective, iteration, average, iteration best, such kind of thing. All right, so refer to the demo application. Try to complete your application as close as possible. Right now, we cannot take advantage. Properties I will show you another. If you want to add it, or if you like to let the user special their own automation problem, probably I will show you quickly. This is probably another problem. So I might call it. So probably I will new. I will copy, paste it. New COP. Okay, so how can we do that? Let me subscribe event. Okay, so if you would like to explore more functionality provided by my DLL, you can add a new button. So I will access the class name. Class name show what the Continue. COP benchmark, right? This is the class. I think that provides several static function. So create a new problem and show editor. Okay, gotta be this function. Display problems on display algebraic values of problem equal load a problem. We just use it. And show edit to edit a problem. And another function is this one. Read the source code. Okay, create a new problem and show edit. So actually this is the equation. And eventually it will return a COP benchmark, right? So COP benchmark new PROBLEM. Let me see what's going on. I cannot exactly remember what kind of functionality has been provided within this function, but I think that will be it to create. To let the user special a new problem. All right. So the editor will prepare this editor for you. So you guys can think, oh, okay, so I might have my sign dimension PR problem, right? It's minimization, dimension is 2, so you might create, okay, dimension is 3, dimension is 2, dimension is 1, dimension 2, maximization or minimization anyway. So it's 2 minus 2, 10 to 9. And non-optima, if you know optima, you can provide information. If you don't have any information, fine, there. And then we have a rich text box file, right? Rich text box right here. So actually, we should write code, right? We should write some, we should add, for example, add equation here. Let me show you if I open Word. Now probably I add something. What is the problem here? So probably I add the equation, right? Add. Do I have a equation? All right, suppose I have equation. See, if I click on it and let me try it. Copy. I might here, for example, problem. Pass it. I can pass. See, what I have done is I pass the equation right there, and also if I have figure. Figure. Okay, anyway, you can try them. Rich text box actually can save a lot of object information. So remember now you can put it. Well, for example, right now we can try it. So suppose I have screenshot, and then I have graphics there. See, I have a graphic here, and I might add something. Okay, and then I select, okay. I copy the graphics and then I can paste it. See, that is the beauty of this rich text box file. So eventually this will save as a rich text file. Okay, so this point, if I choose to use C# language to do the objective function evaluation, see what you actually do is that, see, we are trying to complete this function, optimization problem, global definition right here. So you can define your own global variable here. But the one you need to complete is this function, get objective value. What it have is x. You need to compute objective value. So suppose right now it's a two-dimensional, right? So objective objective. What you are trying to read is try to write a C# statement, probably equal x 0 times x0 plus 2 times x1 x1 plus minus 3 times x0 plus maybe 4 times x1 plus 5. All right, so it's very simple. I complete this statement. Actually, I complete this function specification. So what you supply is the source code, right? So in C#, and then the DLL will compile it in runtime, generate DLL and link with your solver anyway. So I don't have a gradient, I don't have automation problem, so it's okay. And we can check whether this equation is okay or not. So once you click on this guy will invoke a C# compiler, try to compile the code you have written. If it's okay, then your code is okay. See, if I tried it, I delete this semicolon, right? Validate, right? Compiler, check your code, saying that, well, this statement must be semicolon, see? So actually, we ask the user supply the source code C# and then the definition will be complete. So right now I have create a new problem, right? So I can save it. I can save it. I move into the desktop. Okay, so desktop. And the problem is that COP, right? COP in desktop. So a new problem is created. So if you have a complicated objective function, you should spend a little more time on constructing this solution. All right, so done. All right, so I have everything's there. So let us check about the file, the benchmark we just created in the desktop. So we have AAA, RTF, AAA, COP, right? So if you open WordPad by default is for file type is RTF file. You see, this is the content we just add in the rich text box file, equation, graphics. So rich text file. And how about COP? COP file you can use a notebook to display the code. It's okay there. See, this is what has been saved as a COP file. The format has been specified, so you don't need to worry about that format at all. So right now it's about the time to solve my own problem, desktop, right? AAA, COP. All right, this is my function. Okay, so I think it's a square of my square. I cannot remember exactly what I have done. It's not quite right, but it's okay right now. So try to find a minimize, right? So you can invoke your PSS solver to solve it somehow. All right, so you can try your own automation problem by using this easy interface, this command, so user can create a new COP problem. Okay, I think that's all. So what's left, you should do it by yourself. So you go back to the GS solver and SEO solver, follow similar structure, design your own PSS solver, okay?